Duncan Ferguson on the far right, who's Vice President Commercial and Industrial Printing at Epson. Welcome. And then on my immediate left is Simon Edwards, who's Product Champion at GIS Software.
That's right.
So a quick round of applause for the duo. Thank you. So, Duncan, to begin with, I know there's a little bit of news that's come out of Epson over the last couple of days to do with expanding your capacity to manufacture printers. Can you tell us a little bit about that?
Yeah, so the Precision Core thin film printhead, which is our latest generation, we made an announcement 2 days ago. We're expanding production at one of our existing factories in Japan. So it's just in line with demand. It's not as big as the initial investment made 4 years ago, but it's good news because obviously it helps in terms of supply for our own products, but also for the partners that we have. Yeah,
of course. That brings me. My understanding is that manufacturing thin film silicon MEMS heads is quite expensive for the OEM. So is it viable? And I guess my question is there enough demand out there to warrant?
To be honest, the setup costs, the investment costs in a thin film and a MEMS factory are relatively high. But once you've established it, obviously the consistency in terms of production that you get from an automated MEMS factory means you can rapidly bring the cost down over time. So yes, in terms of the initial investment, it's relatively expensive, but ongoing, it's no different. In fact, you get advantages in the midterm from that investment.
Mm-hmm. And so does the cost? I hear some people say in the industry that a printer with a silicon MEMS heads are more expensive. Is that true? Is it a bit of a misconception for the print?
I think it's a misconception for two reasons. Firstly, it may have been the case when they were very first introduced to market, as is often the case with new technologies. And I don't think that necessarily is true anymore. The second point is that in terms of the actual manufacturing of the chip, where the nozzles are, that's only part of the cost of building a head. And then you've got issues of integration. Do you need a heater in it, etc.? There are other cost elements that go towards building a head. So I think the argument is a little bit simplistic when you say, oh, thin films is expensive. It's what the head you require for the application that you are trying to achieve, and how you need to build that head to achieve it. Okay. So actually, if you look at our heads, there is a wide variety of pricing depending on the complexity of the print head, whereas actually it's using the same silicon chip to do to fire the ink. So it's actually about, the cost is often about all the infrastructure around the head rather than in the head itself.
Yeah, I agree with that. It's about total cost of ownership, because I think if you look in the market, actually the differences in price of print heads, which are achieving the sort of tasks that this group want to see, are not that different in terms of the pricing structure overall. And one of the key factors, I think, from our perspective, and because we work with a lot of print heads, of course, we pretty much support all the manufacturers' print heads, is that it ultimately comes down to the reliability of the print heads. Because if it's a consumable item like they have been in the past, where people have got used to changing print heads, then that's a hidden cost that was really hard to quantify until you've built a machine, you've got them in the market. A head that's more reliable and basically performs as expected for a long period of time, of course, means that you've got a lot lower cost of ownership on it. And I think that's quite an important factor.
Mm-hmm. My understanding in when it comes to textile printing, at least digital textile printing, is that the Kyocera KJ4B series is the most popular, but it's not a thin film head, but it still comes at a premium. So why is that printer sort of more popular than other alternatives on the market?
I don't know. The Kyocera guy's not here, so
no.
I think it's one of those things, a time to market.
I mean, you deal with both.
Yeah, we do. I mean, obviously we deal with a lot of them, but Kyocera was time to market. It hit a sweet spot in terms of its resolution, the type of inks that could be used with it. There's a whole range of factors which sort of put Kyocera at the right time in the right place. And one of those things, of course, is from a machine builder. Once you've built a machine around an infrastructure, there will be junction points going forward when you're building next generation machines that you can make changes. But of course, once you've got a head of steam on a certain path, changing that's quite difficult. So I think it's just a matter of timing. I don't think there's anything special about it today that makes it any, more viable than anything else. And there's a lot of options on the market. Epson have come out with quite a really strong range of print heads recently. And I think, there's a few good contenders there. I'm going to be a little impartial, but I think that's probably where it comes from. Okay, so if we focus now on the performance of the thin film MEMS, what sets them apart from the rest? Because I assume there are a number of factors to consider. So you've got drop size, speed, accuracy, resolution. So how does a thin film head compare to alternatives?
So in terms of the manufacturing of the nozzles and the nozzles plate, it's the accuracy and the density that you can get. And this enables you to basically fire far more precisely in terms of where your dot placement is. Also, the MEMS structure of the nozzle itself is perfectly circular. So as you're firing the ink, if you're firing through a perfectly circular nozzle, it will go where you want it to go. If it's not perfectly circular, what happens is the friction on the side of the nozzle, and it will slightly deviate. So that perfectly circular nozzle that you can get really also contributes, along with the density of the nozzles, to that ability for high precision drop placement.
Simon, have you got anything to add?
Well, from our perspective, I think the most important thing about a print head is accuracy and nozzle to nozzle performance. You can do a lot with software, and that's one of the things that we do. Obviously, we do both the drive electronics, the ink systems, and the software. And so there's certain things with print heads and machines generally, which you can use software compensation. So for example, if the nozzles from one nozzle to the next in a print head aren't performing equally, so you're getting different densities and slightly different drop sizes, etc., drop velocities, then we can compensate that by changing the image data. But there's only so far you can do that. So without doubt, a technology like MEMS, which can provide a much more uniform jetting process from nozzle to nozzle, means less compensation, which ultimately is going to transition into a better performance in terms of print quality. The other thing is that, reliability of the head. So I expect a head which is machined to a specification and reaches that more easily from one head to the next. So in other words, the repeatability of the manufacturing process. One thing we have seen in the past with other print heads is quite often you get quite a lot of variation from one print head to the next. And that has a knock-on effect of when you replace a head, you need to go through a much more rigorous calibration processes. You get variation in terms of the overall performance of print heads, so you get different densities. So when you put a print head in, a lot of companies will see initially banding from the heads. They'll see a different density from one head to the next, which can be adjusted for without a doubt. But the more repeatable the manufacturing process, when you take a set of print heads, they will perform more equally, hopefully, and that would be always a good thing. It makes the swapping things out, the mechanics are changing things, less software compensation requires better print quality, and overall the cost of ownership is going to be lower because you can do things more quickly if you need to change a head or when you build a larger array or when you move to more colors, for example, when you've got more print bars in the system.
Mm-hmm. So as an OEM, Duncan, how do you respond to sort of this information from Simon?
Well, just to add to it, really, I mean, the point about the variability to head, you also get a situation where you get variability in terms of over time, you get sort of fading of performance. And with the MEMS technology, you're likely to get the fading of performance over all the nozzles equally. Now, that makes it very easy to just do a voltage adjustment to compensate. Whereas if you've got the nozzles fading at a different rate from each other, it becomes really difficult to compensate. So again, in terms of maintaining the performance of the head over a long period of time, we talked yesterday about how we need to, lengthen the life of clothing, but actually it's the same issue on machinery from a sustainability point of view. How do you lengthen the life of your machinery? Well, if you can do a quick adjustment simply as it gets older and maintain the performance, that's actually quite valuable for the printer.
Okay. So my understanding is that one of the biggest attributes of thin film is the speed. Now, do you find that they are being implemented only in printers that print industrial levels, or is it across the board? Do you find this demand in the lower volume printers as well?
So I am going to talk now specifically about Epson's precision core technology. When we designed it with a modular system. So we basically make a print chip, not a print head. And then we basically use that print chip to build it into whatever form that we want in terms of a head. And what that enables us to do is actually, in terms of development of a new print head, it's now relatively quick because it's effectively a modular design. And that means that we can use the chip in its simplest form, even down to a small office printer. And we are doing that today. So when we talk about scalability, we talk two ways. We talk scalability up, i.e. you design a head like the S3200 or the D3000, which is specifically designed to go into an array the way that it's been designed. Or you can design your head in order to go down to micro production, small format production devices. And again, when you think about the micro factory argument that we had yesterday, the ability to think scalability down is just as important to thinking scalability up. Okay.
If we move on to DPI then, which is a performance factor, it's still working. Okay, I thought the microphone had cut out. Apologies. So if we just touch upon the resolution, then is there an appetite in the textile printing sector for higher DPI? Is there a need for it, or will lower resolution suffice?
It depends what you mean by low resolution. I'm always an advocate of take, for example, 600 DPI head that has excellent performance, accuracy, etc. Over, for example, trying to get very high resolution but not get great accuracy, and you suffer on performance. 600 DPI printing is, when it's perfected, is really excellent. In the textile industry, I don't see a huge amount of appetite for higher resolution than 600 DPI. In other sectors, definitely. In the flexible film and packaging sector, that's what they're targeting. We hear noises about even higher resolutions, which seems slightly unnecessary. But no, I don't think we're seeing a huge amount of appetite. I think we are seeing in the textile industry is looking for variation in terms of print head options that they can choose from, perfecting what they've got, perfecting what's already in the market, and making sure that those machines perform at their best. A lot of this about for digital printing, one of the things that's held back digital printing, not just in textiles but others, is in fact uptime. That's got to be the key. Once you've got print quality there and you've got the resolution that you're after, and you can provide the inks that you want to use, it's all about getting throughput and making sure those machines just keep on going. They're stable, they're reliable, and as Duncan said, they don't drift a lot over time, because that causes all sorts of issues that are quite difficult to manage.
Mm-hmm. I think you touched upon it already, but I think you mentioned about software correction in our calls before the conference. Yeah. Could you go into a little bit more detail about that? Because I'd not heard or was familiar with what it was or how it works. So.
Yeah, so one of the things that in the graphic arts industry and the packaging sector which has held them back, which is what has motivated us to put a lot of effort into software correction and compensation, is in fact that to date, print heads haven't performed equally in terms of within one head to the next, and that we see a lot of print heads which have density variation from nozzle to nozzle. We also have, of course, the complication that you have to stitch heads together. And that means that the junction point between one head and the next, if you don't have the density between them, it is very obvious. The human eye is very accurate and it can see very small shifts in density, particularly when you're looking at prints where you've got large areas of constant color. And it's very easy to see in a lot of cases. So what we developed is a range of tools which allows you to do the compensation. It's not a correction. For example, if you have a missing nozzle, we can compensate for it by changing the image data to change the density of neighboring nozzles. When we do this, particularly say for 600 DPI and up, it's almost indistinguishable that nozzle's missing. And there's ways we can do it either in the single color channel or multi-channel to actually do that compensation. And that's quite an important feature because you do get systems. You will always get somewhere in the system you have a missing nozzle. So we can compensate for that, and that's one part of compensation. What we can't do is correct it. You can never make a nozzle suddenly work when it's not, unless of course you clean it. So from a software point of view, you can't. The other thing is density correction. So you do get variation from nozzle to nozzle within some print heads. And as a result, you will see sort of variations in densities and patterns that you get. So what we're able to do is we can print a pattern, we can test and measure that, and then we can correct every nozzle's density in software by changing the image data. And the difference between an uncorrected image and the corrected image is quite profound. You can go from a situation of seeing in monotone or sort of single color patches, quite a lot of density variation to almost making it indistinguishable. And that's quite an important toolkit actually for a lot of customers are using that now. It's called a density correction and compensation. And it's something that is, you know, I think arguably in some industries has been holding back printers from using their product for premium printing requirements.
Duncan, have you got any comments to make on any of that? Or?
I know I'm going to default to the expert when it comes to software, but he's absolutely right. And one of the advantages of MEMS, again, because of the very accurate placement of nozzles on the nozzle plate, the actual ability to spot which nozzle is out becomes easier. So the verification technology, so he's talking about the software to cure it, but actually in terms of identifying which nozzle has misfired or whatever is much easier because of the consistency of the nozzles on the plate.
Actually, that's quite an important point. It's often difficult to distinguish when you're looking for missing nozzles compared to misdirected nozzles. So actually a print head which has good nozzle jetting direction is very important because even if you get a missing nozzle, at least you know that's what's happened. Whereas if you have print head where you can get jet deviation from nozzles, it's very hard to work out that in fact that jet is misdirected as opposed to just doesn't exist. In other words, it's a missing or a broken nozzle in the system.
I'm interested to know how big the textile printing market is to GIS as a business.
Which market?
The textile printing market, because you cover packaging and other printing sectors as well. So is your software increasingly in demand when it comes to textile?
Textile market for us, very big.
Yeah.
Yes, we've got a lot of customers in the textile industry. It's actually something we've been involved in for a very long time now. And it's a really important sector to us. I mean, we've seen the industry go from very early stage, we were right there at the beginning, all the way to where we are now, where we're seeing very high performance requirements. And, you know, the digital printing of textiles is impressive, to say the least, from the machines that are now being built for the industry.
So we've discovered then that from a technical point of view, thin film heads are the pinnacle at the minute. But what could we do to push the technology further? What's being worked on to sort of make them even more reliable or faster?
Well, recently the introduction of 1200 DPI print head, but also looking at nozzle level recirculation, looking at a wider variation in terms of print drop size. So all of these developments are underway at the moment. So yeah, it's iterations, but without losing that core function, which is the precision that you can lay the drop down.
You mentioned about recirculation. Were there any unintended consequences when that was first introduced to sort of the speed or performance?
No, I mean, effectively, it's just the method of design to move the ink round the print head. So you can either recirculate within the chamber, or you can recirculate as the fluid is going past the nozzle. And it's just, you know, the level of efficiency at clearing pigment, especially through, to prevent agglomeration. So in the chamber is good. Nozzle level is a little bit better. There are other factors that you can use to help in this area, like heating within the print head. But yes, the ability to introduce nozzle level circulation, you know, in a MEMS print head was something, an important step to make. Yeah.
Simon, anything to add on?
The nozzle recirculation, I'm not expert in that area, but I mean, just to reiterate, yes, of course, having nozzle plate recirculation is obviously going to be better than through the back of the manifold. We don't have much control over that process, other than the ink systems we develop. But of course, that's really a print head level activity that we don't have much influence over, I should say, directly.
But at GS, what are you working on? What are you looking to improve upon when it comes to your software?
Oh, we've got a lot of things going on at the moment. Actually, from our perspective, traditionally we started out as a drive electronics manufacturer, and then we moved into ink systems. The software was kind of what we call a driver. In other words, it was just there to get the drive electronics working. In the last 3 years, we've moved quite heavily vertically all the way up to user interfaces, which are positioned for different sectors. So we're really putting a lot of effort into that. But one of the key areas for us moving forward is artificial intelligence technologies. So at the moment, for example, we take the image performance side of things. Typically, to assess issues, problems that you might want to compensate for, you have to print a test pattern. And in printing a test pattern, you have to stop the system, and that can be quite disruptive. So we're starting to work towards an AI engines where, in fact, you can use the actual image that's being printed to detect any problems and in real time, closed loop, correct them in software. So that might go from everything from color shifts that you might get to correct those. It might be detecting nozzle outs. It might be detecting density variations and using an AI engine. Earlier this year, we were acquired by a group called Nano Dimensions, which is an AME company, basically primarily working in the area of printed electronics. But part of that group is also a company called DeepCube, which is one of the biggest entities in the AI field for artificial intelligence. So we're looking at starting to build into our product over the next few years AI engines, which will provide not just closed loop intelligent image compensation, but also looking for things like potential machine downtime before it happens, so predictive maintenance. So part of that's a machine learning engines, and we will look to use kind of feedback from image captured plus possibly electronics to look at potential machine failures. So rather than have a machine go down unexpectedly, you might, for example, have a system that says, we can see that this particular part of the system may well fail or is coming to the end of life and needs replacing, in 7 days' time. So people can schedule that maintenance time. And that means you've got more uptime. So that's kind of the direction we're going. It's going to take us a couple of years to get there. So what you'll see over the next few years is aspects of that coming out in our software platforms.
Okay. Very interesting. I mean, slightly off topic, but very interesting nonetheless. Duncan, have you got any add to the old?
Not putting any AI engines?
Well, no, actually, I'm
improving uptime. Or?
Well, just looking again, talking about what might be coming in the future, and you mentioned was 1200 DPI required? Probably for a lot of textile manufacturing, it isn't. But actually, as you're moving into technical textiles with potential to integrate sensors into textiles for health purposes, etc., that may then create the requirement moving forward. So I think it is important not to dismiss it based on today's requirements. We need to think about what might be coming tomorrow. So yeah, I think that's one area. The other area, again, we heard yesterday about the innovations in dyeing and the jetting option for dyeing. Now, the jetting option for dyeing is massively larger drop than the jetting for printing. In printing, you're talking anywhere between 3 and 20 picolitres. I'm not quite sure what alchemy was, but I think it's around 1,000, something in that region. So that's something that at the moment isn't done through an inkjet printhead, either technology. But there is a requirement potentially to integrate the technologies in one device. And I think what we'll see is the need to integrate multiple technologies in one device in order to hit some of these environmental and sustainability challenges that we saw yesterday.
If you were a betting man, what would the time frame be on that?
I would expect anywhere between a year and 5 years. It depends on the complexity of what you're trying to achieve, honestly speaking. And I think some of the technologies that we saw in the presentation yesterday, I think they have excellent potential, but obviously it may be some time before they become established. So.
I think the other thing is that the future of textiles could be quite interesting. I mean, I have a personal interest in things like biosensors, which comes down to printheads, because I think one place that the future could be is actually printed electronics into fabrics or biosensing, and printheads that can provide that level of complexity in terms of the fluids they can handle could be really quite important. And I could see a future where, in fact, you might print into fabrics those sorts of sensor technologies.
Very interesting indeed. I think we're running ahead of time a little bit, but that's understandable with two-person panel, to be fair. But as a closing question for you both, then, what does the future look like for Silicon MEMS printheads in the textile printing market? Where do you see things heading for the remainder of this decade?
I just see us growing our influence in the market from where it is today. It has grown significantly over the last few years, both in terms of obviously our own branded business, but also in the partnerships that we have. So yeah, I think it's a strong focus for Epson as a company, and I can only see us increasing our presence.
Simon?
Well, I think there's always a place for products which are highly accurate and perform well, and if that's MEMS, so be it. So I just think, yes, there is always, I think all the industries in printing textiles is not dissimilar to others. Accuracy, print heads, reliable print heads, good performance, high quality, high image quality is definitely where things need to be heading.
Great. I don't know if I'll open it to the floor. Does anybody have any questions for the panel on this topic?
Any questions? No, I think you've covered it all then.
Okay. Well done, Simon. Thank you very much. It was very interesting.
Thank you. Thank you.